Alrighty, so here we are with exponential equations notes. We are calling these the 4-2 notes. Our exponential function, let's define that, has the variable as the exponent. So as of the review from our last lesson, that had a number as an exponent, but now we're actually switching that up, and we will have a number as the base and then a variable as the exponent. So, taking a look at our notation, this is what a function of a exponential function would look like. You have your a here, which is actually talking about the starting value. So a is your starting value of whatever it is that you're working with. So we'll do that over here. We like to call it a starting population sometimes, because sometimes they will mention that, but it's that starting amount. And then after that we have our value of b, and depending on if b is between 1 and infinity, so very large numbers, that is going to be your growth. But if it is between 0 and 1, that's going to be your decay. You'll notice that none of these are negative, so b cannot be negative. And if we think about that for a second here, it's because if you take a negative number and raise it to a power, you won't actually end up having a kind of clean line representing them, because your values as you plot them are going to go over to the right, and they'll either be positive because you had a even number exponent, or they'll be negative, and then they'll be positive again, and then negative, and so it won't actually make a function that makes sense, not to mention, yeah, it won't be a function passing the vertical line test. So, other than that, there's other vocabulary that talks about this, so rather than just growth and decay, they may also say that it grows by doubling or tripling, or it has a half-life. And so those will end up giving you values like a b of 2 for doubling, a b of 3 for tripling, or a half-life of a half, or 0.5, for your rate of growth there for b. Alright, so we're going to help ourselves out here by making a graph. So as we take a look at our graph here, we have 2 to the x, which just means that I'm going to take 2 and raise it to the power of whatever it is that's in my x column. So for instance, 2 to the negative 3 will be my y value here. I'll actually put the work over there instead. So 2 to the negative 3, as we remember from our previous lesson perhaps. Whoops, now I have the eraser out. A negative exponent means that it's actually in a denominator as a positive exponent. And then to the third power means that we actually have 1/8. So our first value is going to be 1/8. The next one is going to be 1 over 2 squared, so 1/4. Then it's going to be 1 over 2 to the power of 1, so a half. 1 over 2 to the 0, so just a 1. And then it's going to change because now it's going to be just a positive number. So 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3 is 8. So, on this one, we're going to try to graph. I'm going to graph starting at the bottom, just because you'll be able to see a little better what the pattern is. So, if I go over 3 and up 8, that's that first value at the bottom of my chart. If I go over 2 and up 4, that's the next value. Over 1 and up 2, over 0 and up 1. And so you can see that the points are definitely getting closer together as we're graphing, and they're actually going to start tapering off. So, negative 1 goes to a half, and this is where you kind of have to guess where a half is, just because after that it's hard to, there aren't tick marks that indicate it. And then about halfway to the 0 there, and it turns out at this point I really don't have much that I can graph appropriately. So, as you can see, what happens is that it actually goes closer and closer to 0, but it never actually touches that. And so that actually is what we call an asymptote. So there's this place that it approaches, but it does not cross. Alright, so that's our asymptote there. So, especially as we think of infection rates in this COVID time, the idea here would be, for instance, that this one person at time 0, if you will, could infect another person, and then those 2 people infect other people, and then those 4 people infect other people. And so when we think about the rate of growth or the rate of infection, that's going to be an exponential curve. Of course, then there becomes issues of we're going to try to, and maybe you heard it in the news, we're going to try to level the curve or flatten the curve, and that's because instead of growing, they're trying to make it kind of grow smaller. And so that's like where restrictions were put in so that people wouldn't be out and about too much. I'm sure eventually it'll, just kind of taper off drastically, because that would mean that people are getting the antidote. So, is this growth or decay? Well, we always read from left to right. So from left to right, it's definitely growing. We can also see that the B value is 2. And then consequently the A value is 1. So just as you would see a number out front here, it would be a 1. And then what is an asymptote? I kind of already said that, but it is a value that the graph approaches but never crosses. All right, and so for your assignment here, you're going to do a few where you're telling whether the function shows growth or decay, so you always want to look at the B value. Then you're going to move on to identifying if something is exponential, so by your definition, you might want to reread that about what constitutes an exponential equation. Then you're going to graph some, just as we did, and identify if it's growth or decay. And then the last one here is kind of giving you this biology example. So it's saying, hey, if you had 150 bacteria, which is actually your A value, and it doubles, which is your B value, every hour, we're going to predict the number of bacteria after 12 hours. So they want you to graph it and also write a function because of this A and B. Graph it, and then use that graph that you have to predict what's going to happen after 12 hours. Usually you can use the equation, it's easier. All right, so that is your set of notes today for Chapter 4, Section 2, Exponential Equations.